So section 1.8, it is about simplify expressions, okay? So, what things are called expressions? This type of things, by using variables and numbers and then operations and then put things together, it's called a expression, okay? Well, we need to know how to simplify a given expression, okay? So in order to simplify the given expression, we need to understand these words and phrases, okay? So first, we need to know what are called the terms. We're going to just use this example. Terms are what? Separated by what? Addition or subtraction operation signs, okay? See? These things, they're separated by what? Addition or subtraction signs. So how many terms are there in this expression? Can you count? 7? Yeah, let's count again. 1, 2, 3, 4, 5, 6, 7. Okay, so 7 terms. Okay, yes, you may ask, what are terms? Terms are separated by addition or subtraction signs. Alright. The next concept we need to know is called factors. Okay. So, factors are what? Parts of a term. Okay. Parts of the term. What are the factors of the term 4y? What are the factors? 4 times by y. Each 4 and y can be considered to be what? A factor. Right? Say for example, if we're just using purely number, how can we factor 6 by prime numbers? 2 can be factored by what? 6 can be factored by what? 2 times 3, right? So each 2 and 3 can be called by what? Factor, right? So 2 is a factor of 6, 3 is a factor of 6. Same thing for a term. 4y can be factored by what? 4 times by y, right? So 4 is a factor of 4y. Y is also a factor of what? 4y, okay? So, how to answer this question? What are the factors for the term 4y? 4 and y. I'm going to ask a volunteer to read this question and answer it. Try to answer it. If we make mistake, that's fine, okay? It's totally normal, okay? So Jose, start from you.
A variable is a letter that represents a measurement of something unknown. What variables are represented in the above expression?
Okay, good. So what variables are represented in these above expressions? What variables do you see? Letter. What letters do you see? X and also what? Y. Okay? So variable is a letter that represents blah blah blah. So we're going to check what kind of distinct letters do we have in the expression. So we're going to have X and what? Y. Yes. Okay, very good.
A coefficient is a number in front of a variable, meaning multiply. What coefficients do you see?
A coefficient is a number in front of a variable, meaning for multiplied. What coefficients do you see? So what is a coefficient for this term?
3.
3. Yes, you're right. For the second term 4y, what is a coefficient? It's a number in front of the variable, right? So 4y, what is a coefficient? Number in front of the variable, which is 4, right? What is the coefficient for 7x squared? 7. What is the coefficient for negative 9y? Negative 9, right? What is the coefficient for 3x?
3.
Coefficient for x? Well, this is a constant term. We don't call it as a coefficient. When we call coefficient, it is a number in front of a variable. This term does not have a variable, so we don't call this is a coefficient of something, okay? When we call coefficient, it must be a number in front of a variable, okay? All right, the next concept, Kano.
A constant is a number with no variable. What constants are listed? 16.
Yes, good. Come on.
What is the exponent of the x in the first term? What is the exponent of the y in the second term?
Okay. Exponent of the x in the first term. How do we understand exponent, guys? This little number on the shoulder of the variable, right? So the exponent for this x in the first term is what? 2, right? What is the exponent of the x in the first term, which is 2? Why? Because it's given 3 times x squared, right? Square. This 2 is the exponent for x in this term. What is the exponent of the y in the second term? What is exponent? It doesn't say anything. If it doesn't say anything, it is what? 1 by default. Okay? Yeah, it is 1. Alright. So, Ronald, we lost the concept.
Like terms are terms that have the same variable, same exponent, but coefficients can be different. List all terms that are alike.
Okay. Like terms are terms that have the same variable, same exponent. Okay, same variable, same exponent. Okay, this is important. Okay, but the coefficient may be different. Okay, all of the terms are alike. Okay, so Ronald, does 3x squared this term has any like terms? 3x squared, does 3x squared, 7x squared, okay? So what are the like terms? Okay, so we can write what? 3x squared and what? 7x squared, right? So 3x squared and 7x squared. Now, these, okay, 3x squared, 7x squared. So we don't have to count these two. Now for the 4y term, do we have any like terms to this 4y term? The variable is y, exponent is y, right? Yeah, so 4y and what? Negative 9y, right? Now 3x and x, like terms or no? Yes. How about 16? Any like terms, like constant term, like 16? No. Okay, so we have 3 pairs of the like terms. Like terms, they must have exactly the same variable and same exponent. Okay? Alright, the last term, okay, I will read this. We can only add and subtract like terms. We call these combining like terms, okay? Combine like terms, okay? Do not do this here, okay? Do this here. So, that means, how can we simplify this expression with 7 terms eventually? Okay, so we're going to combine like terms, okay? I'm going to write it here, okay, so we can see clearly, okay? 3x squared, 7x squared, they're like terms. We can combine them. How? Keep the same variable with exponent. Add up what? The coefficient, okay? So 3 plus 7 give us what?
10.
10x squared. Okay? So these 2 terms gone. Now for the y term. We have a 4y, we have a negative 9y. How to combine these 2? 4y and negative 9y.
Negative 5.
Negative 5. How do you get negative 5? 4 minus 9, right?
Yep.
Or 4 plus negative 9. Negative 5y. Then 3x plus x. 4x, right? 4x. And then we have the term 16, no like term, we keep it, plus 16. You guys was good? Everyone? Yeah. Alright, so let's look at these examples, okay? I hope these examples are not hard, okay? In each term, give the numerical coefficients of the variable. Only give the coefficients, which is the number in front of the variable. I'll give you 1 minute to try it, and I'll write on the key for you, okay? Okay, so I write down the answer so you can check. And the last question is -4/5, right? Alright, so let's move on to the next page of the question. Alright, so the next page of the questions are just one type. Simplify each expression, okay? Simplify each expression, okay? How to do it? If we have parentheses, what do? Get rid of the parentheses, clear the parentheses, right? And then we find what? Identify like terms, and then combine like terms. You guys? Alright, so we're going to do some questions, okay? So let's do question C. Okay, so I will say let's do question F together, okay? We're also going to do question H, okay, and then we are going to do question I. Oh, this is L, sorry, okay, L. So we do these questions together, okay, and then you can practice the rest, okay. So, simplify the question C. -4 minus 3m plus 5. How to simplify this? Do we have parentheses? We do. If we have parentheses, get rid of parentheses first. How?
By distributing that one.
Yeah, by distributing the -1. It gives us -4, -1 times 3m,
-3m.
-1 times by +5. Alright. Like terms? No like terms?
Yes.
Constant terms are also called like terms, right? So -4, -5, -9, right? -4 plus -5, what do we get?
-9.
Yeah, two sine numbers, same negative sign. Keep the negative sign, add up the absolute value, right? So -9, and then -3m. Or some of you guys may write -3m minus 9. Is that okay? Yes, because addition satisfies commutative property. Okay, we just learned it. Okay, so
Quick question.
sure.
So, I know we're supposed to do like terms, but does it matter how we can put them? Like, can we put -3m first and then
Yeah,
-9?
yeah, just put on it. Yes, that's right. Or this can equals to -3m minus 9. Why? Addition satisfies commutative rule, right? See, why addition? Because this can be written by -9 plus -3m, right? Plus -3m, right? Interchange these two, give us -3m plus -9, which is -3m minus 9. It's, yes, you are right. I will give you 2 minutes to try number F, and I will check. Okay, so let's look at this question. What do we do at first, guys? What should we do about it? -8 times by the parentheses. Which property should we use to get rid of the parentheses? Distribute. Distributive property. So, -8 times by 7x give us 56x. -8 times by 6. Yeah. Negative 56x minus 1. 58, right? Do everybody get the same answer? H. There are two parentheses. To get rid of these parentheses. How to get rid of these parentheses? Any negative sign in front? No. If get rid of parentheses with no negative sign in front, what should we get rid of it? Keep everything whatever it is what it is, okay? Because it's a plus, right? It's plus sign in front or no negative, so get rid of the parentheses, you still have this. Minus parentheses, what do you do? Distributive property, right? So minus 8x minus what? 7y, right? And then like terms. Like term.
22x.
Yeah, so how to combine these two? 22 minus 8, 14x, negative 14y, negative 7y. Negative 14 plus negative 7 give us negative what?
Negative 21y.
Y. Right? Question L. This one, yeah. 3xy plus 1/4 y plus 2 plus 5x y minus 4. What do we do at first if we have parentheses? Get rid of the parentheses, right? 3/8y plus 1/4 times y. 1/4 times 2. What's 1/4 times 2? What do you get? 1/4 times 2. 1/4 times 2 can be written by 1/4 times by 2 over 1, right? 1/2. Yes, you're right. And then plus 5/8 times y times by, here, careful, okay? 5/8 times by negative 4, right? 5/8 times by negative 4. How? Negative 4 can be written by negative 4 over 1, right? Any common factor between?
4.
Yeah, 4 and 8 give us a 1 and 2. So 5 times negative 1, 2 times 1 actually is what? Negative 5 over 2. You guys agree with that? See, there's a negative sign, negative 5. You can write this negative sign in front of the entire fraction. 2 times 1 gives us 2. Alright, like terms. See like terms? You see that, right? Like terms. Alright, so these three are like terms. However, 8 over 3, 3 over 8, 5 over 8. How about this one? it is not something over 8, right? Can we rewrite 1/4 as something over 8?
Yeah.
Yeah, 2 over 8. What do you think? Now we're able to add up 3 over 8 plus 2 over 8 plus 5 over 8 and see what we can have. 10 over 8, right? What is 1/2 minus 5 over 2? Same denominator. 1 minus 5, right? 1 minus 5. And 10 over 8y, is this in the loose term for fraction? 10 out of 8, yes or no? No. So 5 over 4y, what do you think? And plus 1 minus 5 gives us negative 1, 4, right? Negative 4 over 2, negative 2. Woo. You guys, what's good? Okay, so there are some other questions that you can practice, okay? And then let's look at our last page for today's class, okay? So question 4. Write each phrase as a mathematical expression using x as a variable, then simplify. Okay, so we have this 1, 2, 3 questions. You have questions? Yeah, go ahead. Let's do one together. Okay, let's do one together. Write this phrase as a mathematical expression. Use x for our variable. Then simplify. A number plus 7 added to the difference between 6 and twice the number. What is this number? Do we know? It is x. We don't know. So we assign it to be x. So how to build an expression? A number plus 7. X plus 7, right? Added to, what operation should we use? Addition, subtraction, multiplication, division, which one? Addition, yes. Added to what? The difference between what? 6. Difference between 6 and what? Twice of x. You agree with that, right? You guys see? Now let's simplify this expression. X plus 7. Get rid of the parentheses. Nothing changed. Get rid of this parentheses. Do we have to change anything? Like terms?
76.
Yeah.
Equal to x squared.
Okay. Where does the square come from?
Not because there's 2 x's. I'm sorry.
So when we are adding, subtracting x, we'll just have x. It's not x times 2x. Where if it's multiplication, you will get a square. This is x plus 7 plus 6 minus 2x. So only addition, subtraction will not raise the power of x, right? So x negative 2x like terms, right? Give us what? Negative 2x.
Right or no?
Okay, what is x minus 2x? Let me put it this way. X minus 2x plus 7 plus 6. I'm gonna use addition cumulative to rule. I'm gonna write it here, right? 7 plus 6 like term, right? So what is x minus 2x? Negative x. How do you get a negative x? Remember 1 times x minus 2 times x. So we keep the same x, and then 1 minus 2 give us what? Negative 1, right? Just like you have 2 apples, and then get rid of 2 apples, you only have a negative apple. Yeah, I don't want to use apple, but just like terms, okay? So I have 2 apples, you have 3 apples. How many apples do we have in total? 5 apples, right? Apples are the variables. The 2 and the 3 are coefficient. We're adding, subtracting, and then do that, right? Negative x, and then 7 plus 6 give us what? 13. So eventually the answer is negative x plus 13.